Okay, so now we're going to talk about how we go from moles, which is an amount of a substance, to mass, which is obviously the weight or the grams of a substance that you have, or vice versa. This is a really important concept because what we're going to be able to see is that this is really going to lead us into stoichiometry. Ultimately, if you're working in industry and you are trying to save your company money, you don't want to use extra chemicals. So you need to know exactly how much chemicals you need to use, and this is going to play a huge role, or this step is going to play a huge role in figuring that out. So the first thing that we're going to learn about is something called relative molar mass. If I knew that you had 3 apples and 2 bananas, and I knew that, B-A-N-A-N-A-S, there you go, 3 apples and 2 bananas, and we knew that an apple weighed 0.2 pounds, it's a big apple, and a banana weighs 0.1 pounds, how would you figure out how much total weight you have? Well, I'm going to assume that you said you do 3, because that's the number of apples you have, times the weight of an apple, 0.2, plus 2, that's the number of bananas you have, times the weight of a banana. And that would give you your total weight. All right? Just like that, atoms have weight. When they combine in molecule form, they carry that weight and they combine their weight together, and that's our weight of the molecule. So let's look at, for instance, the weight of sodium chloride or salt, NaCl. We know the weight of sodium, or the average atomic mass of sodium, is 22.99 atomic mass units. The mass of chlorine is 35.45 atomic mass units. So the mass of sodium chloride is going to be those two numbers combined, which is 58.44 atomic mass units. So we would say the relative molar mass of sodium chloride is 58.44 atomic mass units. So I got a question. I pick up one single molecule of NaCl. Does it weigh 58.44? If you answered yes, you're wrong. All right. The issue is that in reality, one atom of sodium doesn't weigh 22.99. One atom of chlorine doesn't weigh 35.45. What determines their weight is the number of protons and neutrons they have. They can't have 0.45 of a neutron or a proton. Instead, that's the average atomic mass. So that's taking all your samples of chlorine and averaging their masses together. So what we're getting at, or what I'm getting at, is that this number right here, this 58.44, that's the average molar mass, or the relative molar mass. It's relative to, it's all relative to carbon-12, and in actuality, we're looking and assuming that if we have a big group of those molecules, that's what the average weight is going to be. In actuality, the weight of one chlorine is either going to be 23 or 22, the weight of one sodium is either going to be 23 or 22. The weight of one chlorine is going to be 35 or 37. And so when you combine those together, you're going to get whole numbers. But overall, the total average of the sample is going to end up weighing 58.44 atomic mass units. The great thing about this is that we can say that if we actually have 1 mole of sodium chloride, it should weigh 58.44 grams. All right, so the units on our relative molar mass go from being atomic mass units to grams per mole. So in 1 mole of sodium chloride, there's 58.44 grams. If we were to look at water, we know that water is H2O. Hydrogen's 1.01, oxygen 16. So if you have 2 hydrogens, that's going to be 2 times 1.01, or 2.02, plus 16. So the average atomic mass, or the relative molar mass of water is going to be 18.02 grams per mole. So what that means is if I have 1 mole of water molecules and I put them on a scale, it should weigh 18.02 grams. Or flipping that, if I weigh out 18.02 grams on a scale, I should have 6.022 times 10 to the 23rd, or 1 mole's worth of molecules of water in that cup. Alright, so let's do a sample problem now, where we're actually going to figure out exactly how many moles of a substance we have based on the mass of the substance that we have. So in this problem we have 80 grams of NaOH, sodium hydroxide. So we're going to write that on top. That's what we're given. We're going to set up our tree. We can put it over 1 because 80 over 1 is 80. We want to put what we want to go to on the top. So we're trying to find how many moles. So moles of NaOH will go on the top, and what we want to cancel goes on the bottom. We're trying to get rid of grams of NaOH. Well, if you add up the molar mass of NaOH, sodium's 22.99, oxygen 16, hydrogen's 1.01, so total that adds up to 40 grams in 1 mole. The molar mass, again, is always how much 1 mole of that substance weighs. So what we can do is we can use our conversion factor there. 1 mole of NaOH weighs 40 grams. So 80 divided by 40. We want to keep our sig figs. There's 4 sig figs there, 4 sig figs there. So 80 divided by 40 tells me that I have 2 moles worth of sodium hydroxide molecules. Alright, so let's try the reverse process here. So this problem says that you need a half a mole of copper 2 chloride for a reaction to completely occur. What mass of that copper 2 chloride would you want to weigh out on your scale? So you would get a scale and you would weigh out, or you would start off with 0.5 moles of CuCl2. You put that over 1. You want to cancel out moles, so that's going to go on the bottom. You want to go to grams, that's going to go on the top. So what you need there is you need the molar mass again. So you'd find the molar mass of copper 2 chloride, which is 134.45. And so we know if we have 1 mole's worth of copper 2 chloride molecules, it should weigh 134.45 grams. Moles would cancel out, and you'd end up with, what's that, 67.2 something or other. And it's in grams, because that's the unit that's left over, so you need to weigh out that many grams of copper 2 chloride. But the big thing there is 1 sig fig, so that would actually round to 70 grams of copper 2 chloride is what you need to weigh out. Right? So when you're converting from moles to molar mass, from moles to mass, you need to multiply by the molar mass, and when you're converting from mass to moles, you need to divide by the molar mass. Check out the next video. That's going to show you how to put those 2 steps, the last 2 steps that we've talked about, together and do a multi-step problem.